All right, I really appreciate the opportunity to take a minute, Mayor, Council, to be here. I think I probably give the impression every time I'm before you that the thing that I'm bringing is the most important thing that we could possibly be talking about.
At the moment it is, sir.
This time I really don't think that's hyperbole. I think that if you'll allow me to wax philosophical a bit, if you look at the pattern of human settlement and distill down to its essence why we live where we live, it inevitably boils down to the availability of fresh water. That's what you'll always find, no matter if you're looking at Rome or you're looking at Seattle or you're looking at Hong Kong or Los Angeles. It always boils down to the availability of fresh water. That's why people settled there. That's why people stay there. And here on the Palouse, we're not the exception. Anybody who has looked at our water history, and several councilors have through their participation in PBAC. We have 3 councilors here that have served there since I've been on there. We have Councilman Steed, Betke, and Councilor Trucio, who all helped with PBAC and have an understanding of the challenges that we face with water. You know, when this area started being settled, there were wells here that artesian wells that just came out of the ground. Lots and lots and lots of water just boiling out of the ground. Our water all comes from aquifers that are deep in the ground that we pump from, and we're really lucky to have this resource. But we've known for a long time that the resource is diminishing. Our water levels have been decreasing for a long time, really, since the 1890s when we started tracking it. So there's been an effort to find a solution for this problem. One of the things that I love about local government is we're forced to be very practical. We have to solve real-world problems. And if there's one charge that I think local government, the most critical charge we have is the delivery of fresh water. Without that, none of the rest of it matters. It's the most fundamental thing that we have to do. And so I'm here representing the Palouse Basin Aquifer Committee. I serve as chair on that committee this year. I'm honored to have with us several members of that committee, including on the council. We have Les McDonald, who sits with me on that committee from the city. We also have Dan Costello with Washington State University. Weber State was where I did my undergrad. But Dan's with us from Washington State University, and Dan is the vice chair this year. And we also have Kevin Guards, the public works director from the city of Pullman, and Kevin's our past chair for PBAC, and really appreciate their support. One of the really inspiring things about PBAC is it's truly a joint effort. We share a basin, and basins don't respect state boundaries. They don't respect city borders. It's just where the water's at geologically, and it's what we have to deal with. And, you know, you hear a lot about water conflict throughout the world, a lot right now about water conflict. And our area is truly developing into a model for the rest of the country for how to work cooperatively. I've been so impressed to sit in a meeting talking about water, something that can be very contentious with the different entities that are involved. You see the list here. PBAC was formed in 1967 because we knew the groundwater was declining. And so the entities that are involved, we have Pullman, Washington, Moscow, Idaho, obviously, Whitman County, Latah County, both of the universities. And we all work together to try and find a solution to this most critical of problems. And today, I'm really happy to be here because we have been working on an alternative water supply study. This is something that's really critical. This is a map that shows the outline of the current basin boundaries. This is something that's being refined as we speak through a study that's taken place with PBAC. It's always, our basin's an interesting basin, and it's one that's required several decades of study to try and define. And so this boundary is the current boundary that we're working with, and we're working to refine it. It may adjust as we gather more information. As I mentioned, these are the participating members. We recently hired a new executive manager, Corey Woodley, who I know some of you have met. Many of you are familiar with Steve Robichon. Corey's been great, very energetic, and we're happy to have her. Steve has stayed on and been gracious enough to help us in a technical advisor role. He's a wealth of knowledge. He's just been working on this stuff for a long, long time, and we're happy and lucky to still have him around and helping us out. This is how PBAC is funded. PBAC is we fund the administrative portion of PBAC. The City of Pullman, City of Moscow, Washington State, and the University of Idaho all contribute equally. Whitman and Latah County a lower amount, and then the City of Palouse has traditionally, even though they're not a member of PBAC, they have donated money to help PBAC along because they recognize the critical nature of the work that we do. And then the research funding. I mentioned how much research has been done on a difficult-to-define basin. PBAC has done a really good job leveraging these dollars with grants in order to gather the information that helped inform this study that I'll be talking with you about tonight. There was a groundwater management plan that was established in 1992, and this was in recognition that we have to do something. We need to set some clear goals, and we need to work toward a long-term solution for our water challenges. In 1992, we had pumped 2.7 billion gallons of water that year. And what was determined in that groundwater management plan, we don't have to read this whole paragraph, I promise, but there was a goal set that capped consumption at 125% of the 1981 to 1985 average, and capping increases in aquifer pumping at not more than 1% per year. And with that, the hope was that the basin would then, that the aquifer would stabilize within about 20 years. This graph here kind of shows the pumping. We've had some successes. The groundwater management plan has been effective. There have been a lot of efforts that have taken place since 1967. And you can see here that we pumped less water in 2016 than we did in 1992. And that's despite a 25% increase in population since 1992. And so what that tells us is that despite the area growing, we're doing a decent job at curbing our water use. That being said, we're still increasing, and we're still seeing a decline in the aquifer, and so we have not stabilized the aquifer, which means despite the good efforts, we've got more work to do. Just as a point of reference, we've seen a 22-foot decline since 1992 in the aquifer. For a long time, the aquifer was declining at about a foot per year, and more recently, we see numbers that seem to indicate more like 0.6 feet per year rather than the 0.9 that we had been seeing. So that's positive. That's a positive thing. But as long as it's still declining, it means we've got work to do. This is one of Steve Robichon's graphs. He always has really entertaining graphs at the Water Summit. And this shows where the water level was in 1890 versus where the water level now in 2016. This chart shows that historic decline, and you can see that we've started to flatten out and not see such a rapid decline as was seen in the past. This breaks down the pumping by entity. These are the 2016 numbers. These are the millions of gallons pumped, and it just breaks down the percentage of the total gallons pumped in 2016. There's some pretty interesting things to note on this and the following slide. You'll see here that we've seen a significant decrease since 1992 in the U of I domestic, in Palouse, and at Washington State University, and while we've seen a little bit of an increase in Moscow and Pullman. A lot of these numbers can be explained by the nature of the communities. As the communities grow, we'll see more people living in the cities themselves, and the amount of use doesn't necessarily correlate to how much is used at the universities. Palouse had some system upgrades that they needed to make that significantly helped with their water consumption. And a big one for the U of I domestic, as many of you will be aware, is the reuse system, the cooperative effort between the city of Moscow and the University of Idaho that allows for the effluent from our water reclamation and reuse facility to be used to water green spaces, including the golf course at the University of Idaho, which saves us millions and millions and millions of gallons of water. So that brings us to the study. So this study outlines, so we set a 50-year water demand projection. The 50-year projection, you know, we don't want to make a plan for 5 years, because with the scale of the projects that we're looking for, with the scale of the things that we have to do to try and address this, these aren't cheap, they're not easy to deal with, and so we want to set a horizon that we think is a good target horizon. And so 50 years was used for this study, and there are some assumptions plugged into this, into the study parameters. A 1% population increase, one of the things that I do want to emphasize that we continually get asked is conservation and how big a piece is conservation. And conservation is huge. I mean, we really emphasize it. Both universities, the city of Pullman has a great conservation program. The city of Moscow has a very robust conservation program. And conservation is built in. There's a conservation assumption, an aggressive conservation consumption or assumption built into this plan. But the fact of the matter is we can't conserve our way out of our water problem. We have to deal with it on the supply side as well. And so I don't want to minimize how important conservation is, but I do think it's important that we realize that we do have to start looking for alternative supplies. One of the other things that I will mention that's included in this, it does include aquifer stabilization. And so there's an amount of water that we assume that we need at this 50-year horizon, and I'm going to try and simplify it, but there are a lot of components that go into that assumption about, okay, how much water are we actually going to need? And the one that I do just want to point out is that aquifer stabilization. And what that means is how much water would it take for the aquifer to cease to decline. And so that number is plugged in there. It's an assumption, but when we break it down to a simple level, about 1/3 of the water that we use is used outdoors. It's used for outdoor irrigation, washing of cars, etc. And you'll see that seasonally. And so obviously we don't see those uses during the winter time. And we can look at how the aquifers behave when that water is not being pulled from the aquifers, and we can look at whether we see recharge or how the aquifers behave. And so a history of data showing that seasonal drawdown leads us to believe that somewhere around that number, that 1/3 of the amount, that 1/3 of the water that we are using outdoors would probably be a pretty good bet for what it would take to stabilize our aquifers. I don't know if that makes sense. It's pretty simplified, but.
Well, why don't we let Tyler finish his comments here?
Certainly, Mayor.
Because there's a bunch of some questions I've got for him as well.
So what this was like, as I mentioned, PBAC was formed in '67. There's been multiple attempts to deal with water issues and to look at other sources. And as a result, we have a lot of studies and we have a lot of great information. And so we started this project with the 40-plus studies that had been generated related to water and our aquifer. And we looked at all of the potential solutions that have been proposed, and then we applied a two-step screening evaluation. And so we could kind of do like a high-level screening for the ones that we knew were just no longer feasible. It might be for ecological reasons. It might be for legal reasons. There were some of them that we just knew weren't going to make it. And we were left, of the 42 that were additionally identified, we were left with about 15 that we could work with, that we could say these are potentially feasible alternatives that we can look at to try and determine how we package these together and how we try and meet that 50-year demand horizon. So we had a multi-criteria evaluation of those. We use quantitative and qualitative issues, which we have to do. If you look at the failures of some of the previous efforts to deal with our water supply issue, a lot of times where they failed is that we had a group of very smart people in a room working on a solution, looking purely at a quantitative, here's the water, here's the supply, perhaps we can do this, without really looking at a lot of the qualitative side of it and without soliciting enough public input. Water is a human issue, and so the humans that are involved in that issue need to be involved in the solution. And so a robust public outreach and bringing those people in is really important. And so that's why we thought it was very important right from the get-go to make sure that we were looking at some of those qualitative things. Couple of things I'd really like to point out that I think are interesting is that we did look at greenhouse gas emissions associated with the life cycle cost of these alternatives. We also looked at criteria air contaminant emissions. And so those are two things that we're considering as we look at what the real cost of these potential solutions to our problem will be. And then there were qualitative things like, water quality impacts, water rights complexity. It's a complex issue anyway because we're dealing with city borders, state borders, universities, different entities. It's a very complex problem. And so these are all things that we have to look at. And public acceptance. What will the public acceptance be of a potential solution? There are certain things that the public is comfortable with in some areas and they're not comfortable with in other areas. And so that's something that we took into account as well. In the end, what we ended up doing is being able to package the alternatives into 4 alternatives that we thought were the most logical packaging of the various alternatives And so they include alternative one, which is a Snake River diversion. This is something that has been proposed in the past. It involves pumping water out of the Snake River and piping it into Moscow Pullman. Alternative two, we have the North Fork of the Palouse River being diverted and piped to Moscow Pullman, Paradise Creek or South Fork of the Palouse for aquifer recharge in Moscow. Number three is one that the City of Moscow actually did a little bit of work on not too long ago, which is the Flanagan Creek storage, which would entail a reservoir on Flanagan Creek that Moscow would then take water from, and then conveyance to treatment for Moscow and U of I, and South Fork diversion for Pullman and Washington State University. And the fourth alternative was a Paradise Creek aquifer recharge for Moscow, South Fork aquifer storage and recharge for Pullman, Pullman water reuse, and groundwater recharge.